So ozone is another big issue. You probably heard of it already several times, and I have already mentioned it several times in this course in the previous chapters as well. We don't directly produce ozone in the troposphere. As you remember, some of you probably already have been through this. In the stratosphere, there is oxygen which gets split by UV light, and O2 becomes O and O, so O combines with O2 to form ozone, and that ozone absorbs high energy UV light, which would be very damaging to us. And as you remember, CFCs, the old refrigerants, were damaging the ozone, especially in the Antarctic region and elsewhere. And Montreal Protocol eliminated CFCs almost completely. Ozone hole has been recovering. So ozone in the stratosphere is good. But ozone in the troposphere is very bad. It's not only a very strong greenhouse gas, it's also terrible for human health, and we will see that it also reduces crop yields by having an impact on the photosynthetic processes and light availability and so on. So the sources here, tropospheric ozone does not have any direct emission sources in the lower levels. Rather, it is formed when sunlight interacts with different pollutants. So photolysis is the key chemistry word there. And here is the stratosphere. In the stratosphere, ozone protects the Earth from sun's ultraviolet radiation, where most of the airplanes fly in the lower stratosphere, upper troposphere, depending on the latitude. But obviously there are issues of aircrafts releasing ozone damaging substances as well, which we will not get into. But there is also other issue of climate change pumping more water vapor into the stratosphere, which is causing problems for ozone formation and can have health impacts as well by reducing stratospheric ozone. Leaving that there, troposphere at lower levels, ozone is a greenhouse gas and air pollutant that is the main ingredient of smog. Okay, so California, which became very notorious for its smog as early as the 1940s and 50s, got special permission from the federal government to create its own air quality standards and fossil fuel emission standards and so on. Has cleaned up its air quality quite well, but as we already saw, there are other issues like PM 2.5 that are still not completely gone. So there is sunlight, the precursors of ozone, which come from either livestock, rice paddies, water stored behind dams, or from coal burning like methane, volatile organic carbons that are also non-methane volatile organic compounds. There is carbon monoxide. Methane is not very stable, so can easily get oxidized, highly oxidizable, can easily get oxidized into CO and then into CO2, but CO is also emitted from industries and so on. Non-methane volatile organic compounds come from inefficient fossil fuel burning in transportation vehicles, and of course they also emit a lot of NOx, nitrogen oxides, which together form ozone. Okay, this is what we have to worry about in terms of its chemical fate. The tropospheric ozone is a powerful greenhouse gas and air pollutant that is harmful to human health, agricultural crops and ecosystems, as we already talked about. The lifetime in the atmosphere is only weeks, but reducing the pollutants that form tropospheric ozone would generate rapid benefits for the climate and human health because its lifetime is so short. So there are what are called short-lived climate pollutants. Methane, black carbon, ozone are all in that category, and they would not only reduce greenhouse gas warming, which can be seen immediately unlike CO2, which even if we start reducing, the impact will not be seen for a while because CO2 is inert, has a long residence time, and accumulated carbon CO2 will keep warming the Earth's climate for a long time, whereas these short-lived pollutants can show immediate impact in terms of greenhouse gas but also on health for both ozone and black carbon and methane and so on. Okay. Impacts, of course, it's a strong greenhouse gas, so contributes to global warming. Health causes 1+ million pollution-related deaths every year. And millions more chronic diseases. It's really damaging to the lungs. Agriculture and ecosystems, toxic to many plants, causes up to 15% in annual yield losses of soy, wheat, rice, and maize. Okay, I think there are some controversies about it, but there is no doubt that there is some damage done by ozone to crop yields. The world's land ecosystems capture and store about 30% of CO2 emissions every year. Tropospheric ozone damages plants and their ability to sequester carbon dioxide, which doubles its climate impact. So ozone itself is a strong greenhouse gas compared to CO2, but its ability to reduce carbon uptake by plants means it's going to have a double whammy effect on climate in addition to health. Okay, what are some of the trends? Here is some satellite data mixed with transport models, source sink models, looking at ozone changes over 1979 to 2006 here in one product, and in another product from 1980 to 2016. But you can see the message. There are hotspots here over India and China in both cases. And of course there is lots of biomass burning in these regions, and you can see these in Dobson units or metric tons per kilometer squared. So this is good to know, because that means the burden of working with the global community to reduce greenhouse gases and air pollution is going to fall on these countries. In addition, they themselves are very keen on growing economically. They are not happy when the economic growth rate is, GDP growth rate is only 7%, whereas most other countries are happy with 3 to 5% and so on. But that comes at a cost. That kind of economic growth with high costs in human health obviously is not sustainable, right? That also has to be remembered. Nonetheless, looking at trends in seasonal average population weighted ozone concentrations in the most populated countries and regions. So seasonal average population weighted ozone in parts per billion. It's a trace gas which is measured in parts per billion by volume. Weighted with population. So this is from the 2017 report going from 1990 to 2015. India is up here, Bangladesh showing massive increases in terms of population weighted ozone increases. Pakistan showing some increase, United States showing a decrease, Nigeria, China, which is China here showing some increase. Japan remains flat for now. European Union shows a decrease. Brazil shows an increase. Russia is almost flat, and Indonesia shows it had a dip here. Could be because of economic and financial issues, and then it's shown an increase. Could be related to deforestation, wildfires, and so on and so forth. Okay. So ozone is a serious concern as a pollutant and as a global warming greenhouse gas. So we will look at some of the other pollutants like PM2.5 again, and contributions to pollution from wildfires and droughts. We already did droughts in the context of water quality. Now we will do that again in the context of air pollution, air quality. Okay.